So, Chapter 15, File Management. We're going to not cover quite everything that's in the chapter in these videos, but I'm going to try to make sure we hit all the important things. What we've got up right now in front of you is the paths within S class from the API. Anytime you see a class name that is plural. Remember, our class names are nouns, right? Anytime you see a class name that is plural, what you're going to have is helper code. This is going to become very important to you a little bit later in this chapter, so I'm going to repeat that a couple of times. When you see a class name that is plural, has an S at the end, that means it's helper code. Helper classes are always plural nouns. That S at the end is the signal to you that that's what you've got. Now, basically, paths doesn't do a whole lot. You'll notice, the scroll bar over here, and that we only have two methods. What paths does is it will create for us an object of a type path singular. This is the only way you can create those objects. There's not really a direct process. There's no way to directly call a constructor. You have to call the get method of the helper code. What we're going to do is provide it, I'm going to have to try that trick. Provide it a string is what we're going to do. You can do it with a URI, but we're going to do a string that represents our file that we want to read. And this is going to be a very simplistic text file read. Okay. I like to start with the simple things. And because I like to start with things that you're familiar with, we're going back to our mass validation. We just did this in Chapter 14. We're going to do this again. We're going to change it, though. That array, that worked, but that's going to get huge if we have an adequate number of test cases, and that's going to be unwieldy. So there is a little bit better way of doing this. We're going to, I don't think it'll let me, there it is. We're going to take a flat file. This has 40 cases. I could put a lot more in it. We're going to take a flat file and we're going to read each of these one at a time, and we're going to pass it through that mass validation that we previously wrote. Okay. So we already have our imports for our pattern and matcher. We need new ones. So what I'm going to do is copy that banner and drop it in here. Imports for file management and I/O. And we'll put one more space in there so they line up. I/O is the shorthand for input-output. Reading a file, writing a file. We've got magic words that I'm going to start using, and you want to make sure that you're getting your magic words lined up correctly. If I am using a file for input, that means I am reading an existing file. If that file doesn't exist, I cannot read it. I cannot use it for input. If I am reading a file, that means I am doing input from an existing file. That's what we're going to do here. Okay. The other version of I/O is output. When I do output, I am writing to a brand new file. That file cannot exist. It must be new in order for me to write my output to that file. When I am outputting a file, I am writing to a new file or data set. Okay, so those are two sets of magic words. There are 3 magic words in each set, and if you were writing that down by any chance, you're going to see that we've got a set of opposites. Input, output, read, write, existing, new. Input and output are effectively inverse operations, and I will say this throughout the videos for this chapter, probably only a couple dozen times. So here are how our import statements are going to read. We will import Java NIO. I will explain what that stands for in just a moment. File paths. This is a helper code. Providing a map to a file. The NIO stands for new input output. Java's been around for a few years, in case you didn't realize that. And when it was first developed, the Java 1.0, there was a lot of input-output code provided. Well, we have a lot of new ways to input and output data now that we didn't have 15 years ago, or however long. I need to brush up on my Java history. And Java says we've got better ways to do that, and we have new techniques, and we have new devices even for some of the things we do. So we're going to build a brand new set of packages. We don't want to get rid of the old stuff. We don't want to say that, you know, the old stuff that you had that worked, you have to change it. We don't want to do that. So we're going to start with brand new stuff. That's what the NIO packages are. They are the newer input-output. Because some of the classes and interfaces are named the same in both packages, you need to be careful which one you're picking from when you import. So be a little bit aware of that, be a little bit careful. The second thing we're going to import, you're very familiar with, we're going to use a scanner. And you really haven't thought of it in this way before, but really what our scanner object is a virtual device, a virtual machine in itself for reading input. Normally we set up our scanner to read input from our keyboard. What we're going to do in this process is we're going to set up our scanner to read input from a flat file so that we don't have to type those 40 or 50 test cases. We don't have to put them into an array. Now what you'll find, I'm going to take a short trip on testing. What you'll find in most corporate environments is that you have a static set of test cases, sometimes referred to as the regression test plan or regression test set. You'll have a standard set. Our code has always worked with these. We've all appropriately has always validated these cases correctly. Make sure that your changes do too. Okay, so a lot of times you'll have those sets that are provided to you. You don't want to retype those. Some of them are very long. I've written regression test plans. Some of them are very long. What you want to do then is be able to read that file in to process it, and that's what we're going to simulate here. Lastly, but not least, we are going to import Java IO exception. This is the superclass for all IO related exception types. Okay, we're not going to worry about getting very specific about what's gone wrong with our input or output. We just want to know whether something's gone wrong. Remember when we did our exception handling and I talked about the fact that you want to basically turn your hierarchy upside down? If it were important to us to see the specific type of I/O problem and to handle each possible one in its own unique fashion, this process would not work for us. We'd have a lot more exception types we'd have to enter here. Because we're really doing pretty simple stuff, and we just need to know whether something went wrong, and then we'll dig into it. Once we have that, we can do this at the superclass level. Okay, let's see. That was all for this. We're going to walk through the code, and in a moment, we're going to write a method that has a lot of comments in it, so I'm trying to cue that stuff up on my other screen. Okay. Not quite stuffing everything into our main, but pretty much stuffing everything into our main. We're going to start here. We're going to declare a private static scanner, but what we are doing is a declaration only. By doing the declare at a global level, it makes this easy to use. That's the only reason I'm doing it. This is not good coding. I will repeat that every time we do this. This is not good coding. It is not secure coding, but it makes our lives a lot easier in this demo. Inside our main, we're going to start by building our regular expression. This is not changed to scrap from the Chapter 14 mass validation. This portion of the code, also identical to what we did in Chapter 14, we will build our pattern called zip pattern. By compiling that regex, we will do this once, not 40 times or 50 times, however many items are in that. How many are there? 40 test cases. We're not going to build our regex 40 times. We're going to build it once. We are going to declare a reference for our string called candidate. We're going to do this above the loop because this is more efficient. Okay, that's the only reason we do it here. The efficiency may not make a huge difference over 40 test cases. If you've got 40,000 test cases, you'll start to see a little bit of a difference. So let's just do the efficient thing. And now we're getting ready to start the real stuff. We have a try block. Everything involved in our input and output, every piece of it must be wrapped in a try block. Every part of what we're going to do must be wrapped in a try block here. When you open a file, that better be in the try block. When you read from the file, the read better be in the try block. If you're writing to the file, the write better be in the try block. When you close the file, the close better be in the try block. Each of those actions is literally asking the computer to do a physical function. Move your read write head here. Prepare that device. Take this data and move it through your buses to that device. Okay, those are all physical functions, and your computer can fail anytime you ask it to perform a physical function. So we need to be prepared for this. We need to set up our little watcher, little creepy elf on the shelf, by creating our try block. And our try block will contain, you'll notice the only thing outside our try block in our main is our catch block. The try block will contain everything. Now this method, open input, we're going to write separately. That is going to create the scanner object based on our input file. That's the real work in this demo, so we're going to do that in a moment. In the meantime, I'm going to talk about our loop. This loop is going to look very, very identical, really, to what we did in Chapter 14. We're going to call that scanner we created, read file. That's really the only difference. Where did we, globally, we declared that read file. We could call it input, we could call it whatever we liked. But we're going to use the has next method on that scanner object to determine whether there's still data. We're going to use the next line method on that object to bring the next candidate in. We're going to build our matcher object based on that candidate and our compiled regex. We're going to test based on that matcher object whether this is valid or not. And when we're all done with the loop, we're going to close our file. Now, technically, with a scanner object, this is not necessary. Beware technical. When you are doing actual I/O, when you are doing I/O, not from a keyboard, but from files, when you're looking at another device, when you were looking at outside storage, your USB drive, a hard drive, an external drive, whatever. Tape drive, yes, we still use them. Always close your file. I don't care how you created it, always close it. Just always close it. Just always, always, always close your file. Any type of object capable of doing input-output, any type of API object capable of doing input-output has a close method. Close your file. Unless you leave your house with your front door wide open, whenever you leave, you just walk out and leave the door wide open. Close your file. Always close your file. Always close your file. Okay? I will repeat that a few dozen more times, I am sure. That's our try block. We're going to catch if something went wrong related to an I/O, to our input-output, related to our opening of the file, related to our reading of the file, related to our closing of the file. We want to know. We want to know. Okay. Really, let me go ahead and add something to this. We should also do ptn print stack trace. That's always a good habit. Okay. Closing is simple. That one's easy. You don't ever need to pass an argument to it unless you get into some really complicated stuff, which we're not going to do in here. So for our purposes, don't need to pass an argument. You just need to call the close. Now, to do the actual, excuse me, opening of the file, let me get queued up. Private static void. Private because we don't want anyone else using it. Static, it's being called from our main. Void, we don't have a return. The method name was open input, and it also accepts no arguments. Okay, let me bring some space up there so this is easier to see. I'm going to start with a block comment because, you know, I'm me. Path is a helper class containing static methods to help us build a map for locating, yes, I cannot spell today, locating a file. And we will have an object called a path when we're done. In this case, we pass the name of the file with the extension as a string to the get method. The method returns a path object containing think about it as a map to our file. Now, we're going to have our file in the same folder with our code, so all we have to do is pass the name. If you need to find a file in a separate folder, you're going to need to pass also either an absolute path or a relative path in addition to the name. We're keeping this fairly simple. We're going to use a file that lives in the same folder. So we already declared our scanner object and named it read file. Now what we're going to do is instantiate our scanner object. What we need to pass to the constructor in this case is a path object, which is what this method will get us. So it's paths with an S get, and we're going to pass it zip candidates.txt. Don't forget that extension, otherwise you're not going to find it. It's going to look for exactly this in this folder directory. Okay. The get method will say, oh, you didn't give me any path information, any directory information, so you mean right here in this folder, right? So I'm going to look for this name in this folder. If you leave the .txt off, it will never find your file. This will work with .txt, RTF, .doc, not docx, .csv, any of those files. This type of I/O will function, and I use it fairly frequently on CSVs, comma-separated values. Okay, so the order of execution here is important. We need to recognize that. We go to the parentheses first. What happens first is the stuff in the parentheses. That would be our call to the get method of the paths class, helper class. We're going to send that string in. Now again, as I mentioned, we have a little bit of a thing. That's a physical function. What we're doing here, this call that I have highlighted here, is actually asking your computer to do some physical thing. So we need to wrap this inside a try block. Come back up and do that. There's going to be a little bit more in our try block. Get this nice and neat. I have that little problem with my tidy code. Okay, so actually that is the end of our try block. We're only doing that. That's what I need to do. This is an actual physical function. We're asking the computer to do something. In our case, we're saying my code is on a USB drive, so I am actually asking the computer to say, hey, look around you in that folder. Go find the directory information for this folder and read the directory information for this folder. Bring that data from the USB drive all the way in through all of those levels of my stack to the JVM, to the heap, and tell me, do you see this thing? There's a lot of physical functionality going on there, and we need to be aware of that. Something could go wrong at any one of those steps, and there are many in there. So what we're going to do here is say catch, and we are specifically interested in that I/O exception. Again, if you don't like my abbreviation for exception, great, use your own. What we're going to do, system error printf. A major error has occurred on file open. Refer to message and stack trace. Period, %n, %s, %n, %s, %n. I know, as long as you get both of these pieces in there, how you space it is not really important. I want to retrieve the specific exception type name because that can tell me a lot. And then I want to see if there's a specific message. Get any message provided by the JVM. Sometimes we'll have that and sometimes we won't. But we're going to see. We're going to keep our fingers crossed. And then what I want to do is always on I/O problems, print your stack trace. Always do this on your I/O problems. It will save you a ton of trouble later. What I'm going to do now, this is what we call a simple rethrow of exception. We want to rethrow this or bubble it up to the main. I have no data, no information to add here. That's why I'm not chaining. I have no additional information to provide. So I am going to come back here. Sometimes having files open when you read them can create problems. So I want to close that. And let's see if I have any typos. Because, you know, I have a typing problem. Of course I do. In why? Oh, CL. My end main needs to be pulled up. I am so silly. Okay. This cannot be inside my main method. Yeah. And I apologize for this, but I do have a little problem with my code not being tidy. It really drives me crazy. Okay, so let's try that again. And I also cannot type. Throw in the body. Oh, I forgot something in our header. Maybe I'll remember this from chapter 11. I have to alert Java that that may happen. Okay. Let me walk. Actually, I will post a separate video walking through the completed code. I don't want this one to run on that much longer. Okay, so we have our data file. I had that open previously. Let me go ahead. Dr. Java is trying to help me out today. I'm not always crazy about that. Here's our input file, our 40 test cases. I'm going to go ahead and close that. As I mentioned, sometimes trying to read a file when it's open doesn't work well. Now what I'm going to do is go ahead and execute that. And isn't that so much simpler than doing this at the keyboard or having to come up with all of your own test cases? Doesn't that make life much easier? Okay, I am going to close this video and then I'm going to start a second one for this that walks through the code changes we made. Okay, thank you.